All right, today we are going to continue with analyzing rational functions. There are lots of different pieces that we need to know in order to get these on graph paper. So we've already done vertical asymptotes, we've done holes, we have done x and y intercepts. So now we're going to look at a different type or two different types of asymptotes. One is a horizontal asymptote and the other one is a slant asymptote. So these two types of asymptotes are used to help us find or discover the end behavior of a graph. And sometimes that's really important. We may not know all the turns and stuff that are happening right away, but the ends of the graph, if we have just our parent rational function, the ends of the graph are determined by horizontal asymptotes. So as x goes to the right, my y value here is approaching 0. As x goes to the left, as the smaller x gets, your y value is also approaching 0. Now that's for the parent graph. So as you know, we cannot cross vertical asymptotes. We can cross horizontal asymptotes, however. Having said that, excuse me, we're not going to show a whole bunch of those that actually do cross. I'll show you maybe one example. There's a way to show it algebraically, whether they cross it or not, and I may or may not get to that. But there are three different types of situations we need to look at when we are trying to find the horizontal asymptotes. And we need to compare the degrees of the numerator and denominator. If you guys recall, the degree is the highest exponent. Remember, we have polynomials on the top and the bottom of these fractions, and we're going to compare the degrees. I'm going to actually start with the bottom, or this one over here. When your degree of the numerator is smaller than the degree of the bottom, we call this bottom heavy. The degree of the bottom is bigger. Your horizontal asymptote is going to be y equals 0. So let's look at this example right here. The degree of the top is 1. The degree of the bottom is 2. This one's bigger, so it's bottom heavy. So our horizontal asymptote will be y equals 0. And what that tells us is that the left side and the right side are both going to go towards the horizontal asymptote. In fact, if it has a horizontal asymptote, your left and your right will always go towards the horizontal asymptote. Without even knowing what this looks like graphically, we will have this horizontal asymptote at y equals 0, and the left and right side, the y value, we can use y or f of x, but y approaches 0. And we can use f of x here if you want. I'll use them interchangeably. Okay, so bottom heavy, it's y equals 0. If the degrees are the same, and this is very common, when the degrees are the same, your horizontal asymptote is y equals the leading coefficient over the leading coefficient. So I always say y equals LC over LC. So the leading coefficient here is 3/4. So this horizontal line, y equals 3/4. And when we graph these, it'll be dotted, just like our vertical asymptotes were. And so the ends of our graph go towards 3/4. The y values will approach 3/4. Okay, now the third scenario is when it's top heavy. The degree of the top is bigger than the denominator. That means there's no horizontal asymptote. No horizontal asymptote. However, there could be a situation where if the degree is 1 bigger than the degree of the bottom, you're going to have what's called, or could have, what's called a slant asymptote. And I'll get into that in just a second. But right now, we're just going to write none for the horizontal. And then the other thing is, we're going to look at those leading coefficients. It does not go towards any type of horizontal asymptote. That means the ends of your graph are going to go to the infinities. How do you know which one? How do I know if y is going to go towards positive infinity or negative infinity? Well, you're going to look at the leading coefficients. Think of this as a line. You have a positive 3 over positive 1. If the leading coefficients give you a positive number, it's going to go up to the right. Just think about slope, okay? then that means the left side will go down to negative infinity. So the ends of the graph, something like that, but it's supposed to be arrow, but it's going to go towards the infinities. Okay, now if that was a -3 over x, then these would be switched. Okay, the right side would go down and the left side would go up. So very similar to when we did polynomials. Okay, so bottom heavy, the degree of the bottom is bigger, it's y equals 0. The degrees are the same, it's y equals the leading coefficient over the leading coefficient. And if the degree of the top is bigger, there's no horizontal, and you're going to check for a slant. So let's go ahead and do 4 examples here. Just make sure we're on the same track with the end behavior. Okay, this is bottom heavy, so it's y equals 0. That means my y values both go to 0. Okay, and then the y-intercept, plug in 0 for x. This is just a great practice on how to find y-intercepts. Oh, let's reduce that, sorry. It's going to always reduce. -3 over 15 is a -1/5. Okay, up here, notice we don't even have to factor to find any of this stuff. The degrees are the same, so it's y equals leading coefficient over leading coefficient. That means my y values go to 1/2. And the y-intercept, plug in 0 for all the x's, you get -1 over -1. Okay, down here, it is top heavy. Okay, 3 is bigger than 2, so there's none. Look at the leading coefficients to decide if that's going to be positive or negative. Because this is negative, the right side is going to go down to infinity. The right side, excuse me, that's the right side. Right side is down and the left side is up. And the y-intercept is 0 over 0. We plug in 0 for all the x's. You get 0 over -4, which is 0. Okay, last one. The degrees are the same. They're the same. It's leading coefficient over leading coefficient. The ends of the graph will go towards that horizontal asymptote. Plug 0 in for x. And the y-intercept is 4. So the horizontal asymptotes really are helping you with the end behavior, but more importantly, it's helping you with some of the y values, right? That's why we added it in the y-intercept here. Okay, let's take a look at the next one. Slant asymptotes. Okay, so a slant asymptote, think of this as a diagonal. It's going to be a line, and it's going to go like that or like that. It's either going to go up or it's going to go down. Positive slope, negative slope. This only can occur when it is top heavy, but it also has to be exactly 1 bigger. So if you had x to the 4th over x squared, it can't have a slope. So if you think about this for a second, you cannot have a horizontal and a slant at the same time. That's not going to work because a horizontal only occurs when the degrees are the same or if the degree of the bottom is bigger. So again, slants occur if the degree of the top is 1 bigger than the degree of the bottom. Now, how do we find that equation of that line? Well, we're going to use synthetic division or long division, depends if we have a linear divisor or not. If you can factor and cancel, sometimes we can make it and force it to use synthetic division. All right, so let's go ahead and take a look at this first example. As you can see, the degree of the top is 1 bigger than the degree of the bottom. So this is none. And we're going to check for a slant. So what you're going to do is you do synthetic division. Because it's a linear divisor, you can't use synthetic division if it's not a linear divisor. So 1 goes on the outside, +1, not a -1, +1. And don't forget, you have to plug in zeros for placeholders. So this is x squared, x to the 1st, and your constant. 0 goes there. Add the columns, multiply. Add the columns, multiply. Add the columns. So remember, this is your remainder. This is your constant. This is x to the 1st. Now, to have a slant, you have to get a remainder. Okay, if it's 0 right here, it is not a slant. You have to get a remainder in order to have a slant asymptote. So your equation of your slant asymptote, we write in slope-intercept form. Y equals 1x plus 1. And then if we're going to graph this, I want you guys to see what this looks like. Y-intercept is 1. The slope is 1. And I'm not going to be able to draw a straight line very well, but it's dashed. And so my pen is not cooperating. There we go. Our y values are going to go to the infinities. As x goes to the right, y goes up. As x goes to the left, y goes down. And it's based on the slope, okay? And we could have answered that question really without having the graph, because the slope or the leading coefficients were positive. Okay, over here, it's top heavy, so there's no horizontal asymptote. I guess we are to graph all of this. Let's go ahead and factor this. Okay, so we're gonna have a hole. I don't know if we really need to graph all of this. I think it's fine. Okay, so there's no horizontal. We're going to have a hole at 5, 7, right? You canceled the x minus 5, so the x coordinate is 5. Plug it back into the simplified equation, you get 7. I think that's it. Okay. We have an x-intercept at a -2. Y-intercept is +2. Okay, we're going to check for a slant. 5 on the bottom. Add the column. And notice we get 0. If there's a remainder, or excuse me, if there's no remainder, there's no slant. This is a line. Whoa, that's supposed to be a line. It's the line y equals x plus 2 with a hole in it. All right, so as x goes, and again, we could look at the leading coefficients. Has a positive slope. Right side goes up, left side goes down. I always do the right side first. So this one does not have a slant. The graph of this is actually just a line with a hole in it. All right, this is top heavy. There's no horizontal. Let's check for a slant. Put the leading coefficients across the top. Okay, we get a -18. That's good. So we have y equals x plus 8 is your slant asymptote. It's positive slope, so my y is going up, or my right side is going up, and my left side is going down. Okay, and you can just solely do that based on the slope of your slant, or you can look at the leading coefficients, okay? All right, one bigger, no horizontal. Let's check for a slant. 1 on the outside. Okay, y equals, and I really don't even need to calculate that. Once I can see that I'm going to get a remainder, I don't need to do that anymore. Okay, it has a negative slope, so my left side, or excuse me, my right side goes down, and my left side goes up. All right, top heavy, no horizontal. Let's check for a slant. Okay, and that is a new, has a remainder of 0. And no slant, and it has a positive leading coefficient, so the right side goes up and the left side goes down. Okay, and that's just looking at these and making sure if this is positive, it's going to go up to the right. Okay, so here is one where we can't do synthetic division. So this is a good reminder of how to do long division. Remember, when we do this, we need to put in placeholders for any missing terms, so it helps us keep this lined up. So x to the third plus 0x squared plus 0x plus 2. Okay, x squared times what gives you x to the third? X. Distribute all the way through, line it all up. Draw a line, subtract. X to the third minus x to the third, gone. 0x squared minus x squared is a negative 1x squared. 0 minus 0, carry down the 2. X squared times what gives you x squared? Negative 1. Multiply, distribute through. It's supposed to be a minus 1. Draw a line, grab it with parentheses, subtract. Cancels. That's going to be a positive x, and 2 minus a negative 1 is 3. So we have a remainder of x plus 3. So that's good that we have a remainder. That means our slant asymptote is y equals x minus 1. Has a positive slope. So my y is going up. My left side is going down. All right, let's take a look at the next page here. This is just, I'm not gonna go over all of this, but this is just a summary of how to find things. Our places of discontinuity, that's dealing with all the x values, your whole, your vertical asymptotes, your x-intercepts. Your horizontal asymptotes deal with the y values. You can cross horizontal and slants. We didn't have one yet. And then we find our x and y intercepts. And then we're going to sketch here shortly, but I just wanted to kind of remind you about like the difference between when it's in factored form. So let's do like x plus 2. This is factored form. So what are the things we can easily find from factored form? Okay, this is all your x stuff. X-intercepts, vertical asymptotes, holes, domain, of course. X-intercept, yeah. So these are like all your factors. Okay, the factors give you these things. Expanded form is your y stuff. Okay, so this is like x squared minus x minus 6. Okay, this is your range, your slant asymptotes, horizontal asymptotes. This is your end behavior. How about your y-intercept? Okay, all that stuff is found when it's in expanded or extended form. Okay, I just wanted to go over a few things there. All right, so this last page is just practice. I'll do all of these. Actually, I'm going to probably do all of these, so just hang tight. Fast forward, pause, do whatever you need to do, but I'm going to do all these examples, okay? All right, so we're going to find it all. This is where it's all put together, right? So domain, x cannot be, remember we're going to set that equal to 0, subtract 2, divide by -5, so x can't be 2/5. So the question is what's happening there at 2/5? Is it a hole or is it a vertical asymptote? And we're not canceling anything, so there's no hole. You have a vertical asymptote at 2/5. Horizontal asymptotes, compare the degrees. The degrees are the same, so this is y equals your leading coefficient over leading coefficient. These cannot exist at the same time. X-intercepts, zeros of the numerator after you've canceled, when nothing canceled, and y-intercept plug in 0 for x. End behavior always goes towards your horizontal asymptotes. If you have a horizontal asymptotes, that is what the ends of your graph, that's what they're going to approach. Okay, all right, let's factor this one. Okay, nothing cancels. Our domain, -infinity to 2, union 2 to 4, union 4 to infinity. We're going to have 2 vertical asymptotes because nothing canceled. Bottom heavy, degree of the bottom is bigger, so this is y equals 0. no slant. X-intercept, -7, 0. Y-intercept, and this always goes towards the horizontal asymptote, so it goes towards 0. Okay, all right, X cannot be a -1. It is top heavy, so no horizontal. We're going to check for a slant in just a second. Nothing cancels. Can't factor that. Vertical asymptote, X equals -1. Okay, so let's check for a slant. Put -1 on the outside. -2, 0, 5. Don't forget to put in this placeholder. Add your columns, multiply. Add your columns, multiply. We have a remainder. Your slant is -2x plus 2. Remember, this is your remainder. This is your constant or your y-intercept. And this is your slope. Okay? X-intercepts, goodness, what is that? Let's see. We got to set that equal to 0. Let's come over here. -2x squared plus 5 equals 0. All right, we're going to have to rationalize that. Multiply the top and the bottom by the square root of 2. So you get the square root of 10 over 2. Yep, so you have 2 x-intercepts. I'm going to go ahead and just write them as 1. Y-intercept 0, 5. Plug in 0 for x. And it goes towards the slant, but be careful, your slant has a negative slope. So that means my right side is going down and the left side is going up. Okay, let's come over here and do some factoring. Let's see, take out an x squared, you get x plus 1. Let's say take out an x, you get x squared minus 4x plus 4. That's going to be x minus 2, x minus 2. Nothing cancels. Haven't had a hole yet, have we? No. All right, so negative, there's a lot. Negative infinity to negative, nope, to 0, sorry. Union 0 to 2, union 2 to infinity. You have 3 vertical asymptotes. No, I don't know why I said that. That's a double root. Sorry, I'm losing my mind here. Sorry. Okay, horizontal asymptotes, the degrees are the same, so y equals leading coefficient over leading coefficient. X-intercepts, looks like, oh, you know what? We have a hole. I messed up big time, didn't I? Sorry. I'm not doing a good job here. All right, let's try that again. Sorry, I forgot to cancel one of the x's. We do have a hole. So that's going to be x plus 1. Sorry about that. You have a hole at 0, 0, right? I canceled an x, and if I plugged in, which is 0, so if I plug 0 back in, I still get 0. So 0, 0, that means we do not have, sorry, we do not have a vertical asymptote at 0. All right, let me get back to it here. So now we're ready to go. You do not have an x-intercept at 0 because you have a hole there. So that one doesn't matter, but we have -1, 0 for the other x-intercept, or for an x-intercept. Y-intercept, none. None, because I have a hole at 0, 0. Can't have a y-intercept and a hole at 0, 0. The hole wins. All right, so this goes towards 1. The y's go towards 1. Sorry, I really messed that one up, didn't I? All right, let's try the next one. Let's factor the bottom here. Difference of squares. X cannot be positive and -8. Okay, nothing cancels. Vertical asymptote, x equals 8 and x equals -8. Horizontal, it is bottom heavy. Okay, x-intercept at 0, 0, and guess what? I'm allowed to have 0, 0 here because this is a horizontal asymptote. This is actually going to cross at the origin. Okay, this is top heavy, and the degree of the top is 1 bigger than the degree of the bottom, so I'm going to come over here, I'm going to do synthetic division. Y equals x plus 5. X-intercepts, we're going to have two of them, negative 4, 0, and 1, 0. Y-intercept is 0, 2. And positive slope on the slant, so my y's are going up to the right and down to the left. Okay, last example. Let me extend this. All right, let's factor the top of that. Okay, we're going to cancel those x plus 3's, but let's do the domain first. Okay, cancel the x plus 3's, and we're left with x plus 3 over 1. All right, so negative 3 is the x-coordinate of our hole. Plug negative 3 back in. We're going to have a hole at negative 3, 0. No verticals. Horizontal, it is top heavy. The degree of the top is 1 bigger than the degree of the bottom. Let's check for a slant. Don't forget to plug the 0 in for the linear term. We got 0 as a remainder, so there's no slant either. X-intercept, zeros of the simplified, that's not x plus 3. I messed up. Sorry, messed up again. I wrote that wrong. You probably caught that. See, what's best about finding mistakes is you can go back and fix them. This is x minus 3 over 1, so plug in a negative 3, that's a negative 6. Sorry, your hole's negative 3, negative 6. All right, so there's no slant. Your x-intercepts, zeros in the numerator. It's going to be 3, 0. Y-intercept is 0, negative 3. And as far as the end behavior, the leading coefficients are positive. So up to the right, down to left. As x goes to negative infinity, y is going to negative infinity. All right, so that particular one is a line with a hole at negative 3, negative 6, something like that. That's not dotted, that's solid. Anyway, that's what that one looks like graphed. It's a line with a hole in it. All right, sorry guys, I made a couple of mistakes there, but I think the rest is good. Hopefully this is helpful.